Hello, everyone. Welcome to the LIUniverse. I'm Dr. Charles Liu, your host. Of course, you must call me Chuck. With us, as always, is our co-host Allen Liu. Hey, Allen, how's it going?
Hi, it's going good. I wouldn't say must, but I'd say recommended.
Oh, that's true. We do not want to take away the free will of our listeners. That would be a little silly. It's just a podcast, after all. So,
Fair.
experienced any interesting geological formations recently, Allen?
Probably. Let's go with the Palisades.
Ooh,
We're sort of in the New York general area. Those guys are fun. They've got the big columnar basalts
wow.
right across from Manhattan, so those are fun.
Yeah.
Those are probably the most cool geologic formation I've experienced recently.
Yeah, and to think that, in the 1700s, as New York City was being besieged or invaded by the British, George
Yeah,
Washington had to scale those palisades with like
yeah,
ropes and stuff.
yeah,
Uh, you know, that's really amazing.
yeah.
Today,
Well, him and the entire army, not just him.
right? I mean, today we
Yeah,
just go across on the George Washington Bridge. I'm like, oh, that's pretty. It's a whole different
yeah,
dynamic.
yeah.
Anyway, we have with us today exactly the right guest person to talk about that and all other cool things about geological formations here on Earth and in the solar system. Everyone, please welcome Dr. Sam Tramontano. Sam, hello, welcome.
Hello, hi everyone. Hi,
Yeah,
thanks for having me.
sure, it's a real pleasure. Now, you are currently at the American Museum of Natural History, but you've had a little bit of a path to get there, so we want to hear all about it for a second. Tell us a little bit about who you are and what you do.
Yeah, sure, happy to. So I'm in my office right now in the American Museum of Natural History. And I think a fun fact that people don't realize is that besides all the exhibits that are on display, the museum hosts a number of different academic departments, research offices, lab spaces, and collections areas. So I'm in the Earth and Planetary Science Department, which is situated behind the dinosaurs somewhere on the fourth floor. But
Ooh.
before I got here, I started my, I guess, uh, love for rocks and the outdoors. Not too far in Staten Island, New York, was where I grew up.
Oh, nice.
Hey!
Yeah, and I didn't stay there for too long because I started commuting to high school to pursue music at the
Oh,
Performing Art Fiorello H. LaGuardia High School. For anyone who's familiar
oh
with New
yes,
York,
fame! I want to
yeah.
live forever. Yeah.
So I commuted to Manhattan by boat every day. I got to really
Wow.
take in the outside every day on my way to high school.
Nice.
And
Melanie
then
Griffith, Working Girl, right? Let the river run. Let it. Did you see that movie ever when you were a kid?
I did not.
Oh, it
It
might be
features the
fun.
Staten Island
It
ferry in it.
features the
Yeah,
Staten Island
that's
Ferry prominently. It's
I'll write it
lovely.
down. Okay.
Anyway, please continue. Yes, so from LaGuardia, you headed to
So
do
from
music
LaGuardia, I
stuff.
headed to the University of Rochester, which has this
Aha!
amazing conservatory of music. So I got to
Yes,
continue pursuing saxophone, which was my main instrument.
named
And
after Julian Eastman, that conservatory, the founder of Kodak Corporation. Yeah.
yeah, and Rochester was a big home for Kodak and other film great companies at
Hmm.
the time, Xerox as well.
Yeah.
Uh, and I loved it there. It wasn't until I took a field trip with an intro course that paid for my spring break that I was able to
Oh.
see mountains for the first time as part of this student in a study group. So there was like an
oh, okay.
educational study, and those flyers where it's like, be part of our study for, in exchange for, a gift card or something. This was, come with us for a week. You learn some geology. It's a course, and we'll cover your flight costs if you let us put microphones
Oh,
on
that's
you.
awesome.
Wow.
So I was part of this
Nice.
educational study, and it took me to see the active margin, which is just the active part of our continent on the West Coast,
Mm.
where earthquakes and volcanoes have been much more recently active. And I've been
Okay.
pursuing some form of earth science ever since, but I'm
Wow.
not given up on
Very
music
fun.
totally.
That's fantastic. What a great thing. We will get to that for sure. We have so much to discuss and lots of questions for you from our audience about volcanoes, both here on Earth and in space.
My favorite.
Uh, yeah. But for now, we go to, as usual, our joyful, cool, cosmic thing of the day. Now, Alan, you actually were the one who pointed me out to this not too long ago that the Juno
Pointed this out to
spacecraft,
you. Yeah.
yeah, had done 2 close passes over Jupiter's moon Io, right? I mean, I suppose I should pronounce it
Very fun.
Io because that's kind of the more correct way, but we'll say Io
Uh,
for the heck of it. Uh,
I think astronomers usually say
yeah, at
IO.
least
I
I
think
won't
Eo
say
is
10.
closer to Koine Greek,
Yeah.
but
If I don't say
yeah,
10 or if I don't say low, then I'm pretty good. Um,
yeah, it's
But
fine.
yeah, the Juno satellite did 2 close passes in the recent past. Both of them were under 1,000 miles, I think, away from the surface, which is much lower than even, say, the GPS satellites here on Earth orbit, the Earth
Yeah.
surface. And we're able to get incredible new pictures of Io. We already knew that Io was tremendously active in volcanoes, but what they found recently was amazing. I mean, first of all, right, we know that Io has such strong volcanic activity that the surface
Yeah.
is essentially repaved every 10, 20 years. So we were looking at brand new mountains, brand new features, brand new everything. So that
Yeah.
alone was pretty cool. But then what they actually found, I thought the super coolest things amongst the many things that they found was that there was actually an island in the middle of a sea of lava, like a lava
Yeah.
lake and an island
I've heard
already
about
formed
this.
inside this. That's
I've
amazing.
heard about this
Yeah,
one.
I
Yeah.
mean, I can't imagine
It's
that like happened
kind of
so
epic.
fast, just 10 minutes. Oh, well, 10 years, I guess, 10 minutes
No.
in cosmic time, but just 10 or 20 years. And this thing came out of nowhere. I think that
I
is
think
pretty awesome.
if I recall, this is like a really so like the things that are permanent on Io are the lava lakes themselves because they're the things that are causing the rest of the
Yeah,
surface to
oh,
get
I
open.
see. Well, that
So
makes,
if I recall, and Sam, I'd love to hear your view on all of this. What's going on is like you have this lava lake that's just sitting there and it's constantly churning up fresh lava from the bottom of it, but the lake itself is a fairly permanent feature.
Well, lava lakes are fascinating. We only have a few on Earth, right? Let
mhm.
Yeah,
alone ones that we can detect off planet, right?
right.
And
Yeah.
the mechanisms that keep and sustain that activity are not
Mhm.
super well understood, right? You
All
need to
right.
kind of have, there's a couple of different mechanisms to keep that heat flow, to keep volume, to keep gases that allow for this lava to persist at the surface because it's a rare occurrence.
Yeah.
And
Now,
Yeah.
on Io, of course, we suspect that it is the tidal interaction between Io's core and Jupiter, its host planet, that
And also the neighboring moons too.
yeah,
Yeah.
it continues to churn the interior and produce all that heat that allows all that heat to come up from the interior outward. But Earth doesn't have that kind of effect anymore, does it? I mean, did it ever?
well, there's always gravitational forces on all of our spherical bodies, right? You
Mhm.
know, but
Fair.
the amount of gravitational pull that creates a tidal effects on Earth is significantly smaller than what Io experiences, right? Because Jupiter is such a massive body, right?
Yeah.
We do have
Because
tidal
we're getting
effects.
pulled on by like the moon and the sun, right?
Yeah, the moon and the sun are our big players on
Mhm.
Earth,
All right.
us earthly inhabitants.
Yeah.
Um, but whether or not it has not been linked to lava lake, persistent lava lake behavior, right? Lava
Wow.
lakes tend to
All right.
persist despite tidal fluctuations. So they
That's
can be
interesting.
open and active for years at a time, right?
Wow.
So what scale are we talking about here? Because I know on Earth, like, so the one lava lake that I got a chance to see up close was Kilauea, which is
Oh, I'm jealous.
probably
I've never seen that one.
I got to see it. I didn't get to like look over the edge because there was a big railing like don't go past here. But I did get to see the crater that it was in. And that's like it's pretty big on a human scale, but how does that compare to like Io's lakes? Because those are like hundreds of miles across, right?
Oh, that's a great question. I don't know the size of. I mean, Io is smaller, but I don't know about the size of the
Yeah.
lava lakes.
I'm gonna look that up because I
Yeah,
remember
I'd be
hearing
curious
about this.
myself, but were you there before the 2018 eruption?
I think I was, yeah.
Yeah,
So it
so
would have been 2016 or 17. It was like real close.
you were
But
lucky.
yeah,
Then now you can't get close at all. The observatory
Really?
has been compromised by the 2018
No,
eruption.
really? This
Yeah,
is the stuff
so
that like made the news
mhm.
internationally when the lava like flowed to the ocean from there.
Yeah,
Oh,
so there's a rift zone that's linked to that lava lake, and
mhm.
as lava drained from the lava lake, it emptied outside of a different location along these different discrete openings, these little
Oh
cones
oh
along the
wow,
no.
fissure, along the rift
dang,
zone, and that was unfortunately in like residential neighborhoods, right? And that's where it
Yeah.
went
yeah.
to the
To the
Yeah, a
ocean.
lot of
ocean.
people had to evacuate, right?
Yeah, yeah.
Wow. And so now no visitors can go see
Uh,
anymore, at
you
least for a
cannot get
while?
anywhere near as close, right? And so, even though the
Okay.
lava lake has had moments where it has been more active again,
Mhm.
you might be able to see some incandescence or glowy orange light
Oh,
from the distance, but you can't quite go up to the rim like you used to.
wow.
Yeah.
Wow.
So I'm looking this up. Io's biggest lava lake, the one with the island we're talking
Yeah.
about, it's called Loki,
Ah.
and it is 126 miles across. So
Whoa.
that's 200 kilometers for all you people outside of America.
Gee.
Um, and compared to that, like the ones on Earth are like one.
Yeah.
So
126 miles, and Io itself is less than a quarter the diameter of our planet Earth. So
yeah,
just in terms of
it's like the size of the moonish.
percentages, yeah, that's
Right.
amazing. But even
Yeah,
126
definitely.
miles, wow. Uh, plunk that down in New York, it'll reach all the way to Philadelphia. Oh my goodness, pretty
Wow.
scary.
Dang.
All right, do we
Yeah.
have a question from the audience for Sam, Alan?
Yeah, we've got a few questions. I'm going to start with one that seems relevant to talking about volcanoes in space.
Okay.
So this one, we were talking about volcanoes on Earth. We've talking about them on Jupiter's moon Io. Question is from Ellis, who is asking, are there volcanoes on Venus?
So there's
Oh,
this is a great question. I am eager to talk about this one because there's some promise in the future
oh,
for us to learn more
Oh,
about volcanism on Venus. I think this is going to be
okay.
a real emerging avenue for scientists that work on planetary uh, morphology features. Uh,
cool.
Okay.
there was this Magellan mission by NASA that went up in
Yeah.
the 90s that was able to take a number of data sets and collect information about the surface topography and shape of Venus. And it wasn't until recently that a scientist was looking back at this data, this is in the last couple of years or so, that there was evidence that, you know, underneath an area of Venus, there was some bulging that was
Oh,
Oh,
uh, detected between two passes of
okay.
oh,
of a satellite, right?
uh-huh.
And so while I'm hesitant to, and I don't really know the full stance on this, if it's definitely volcanism or not, it's definitely geologic. I always am hesitant to say geo. So
Cythereologic.
Planetologic,
it's
yes,
definitely active. If it was on Earth, it would be geologically active.
yes,
Yeah,
yes.
And
yeah.
the methods that this scientists use are similar to what we use to monitor unrest at volcanoes. So it's the study of deformation of the surface. And, you know,
Okay.
when
All
new
right.
volume comes in, it distorts the surface and you get
Hmm.
this bulging or rising of the surface.
Yeah.
So,
Wow.
So would this be like the same way, like, so we were talking about Hawaii volcanoes
mm.
earlier, like where there's like a bubble of magma that's causing this bulging, or is it something likely to be something else?
Yeah, I mean, it's at the very least a change. Something is changed beneath it, right? Something
Okay.
has
Yeah.
either moved in that direction, something has expanded, and so whether or not it's something new coming in, or perhaps bubbles expanding,
All right.
flushing through the surface. There's a lot of different processes that can cause volume changes at the surface.
Mm.
Okay. So
But it's a clever uh, uh, you have to be a clever scientist to kind of untangle what those processes are, because magma is a 3-ingredient recipe. It could be
All
bubbles,
right.
solids, or liquid, right?
Okay.
Solids,
That's a fun
liquids,
way of putting
or
it.
gases.
Yeah,
Ah.
3-phase flow. So
That's a
Fancy,
fun
fancy.
word.
Well, I
Or phrase, I guess.
yeah, I actually never took earth science when I was in junior high school. It was an accident of scheduling. So there's a lot of stuff about earth stuff that I have very little knowledge about. Like, but when I
Mm.
hear the words, they make a lot of sense and a lot of fun. But one thing I do know is that you, Sam, are teaching teachers at the museum, right? That's one of the things that you're doing in addition to your research, aren't you?
Yeah, I am. It's so awesome because, right, I went to public school in New York City, right? I was taught by New York City public high school teachers, and now I get to teach the teachers that teach new earth scientists. It's really exciting. I work with the Masters of Arts and Teaching program here,
Wow.
and very specifically, I work with it's this 15-month program for teachers to be,
Hmm.
and I take them into the field and
Oh,
Oh.
show them
fun.
the local geology. We absolutely go to the Palisades. That is
Uh-huh.
like one of
Nice.
the New York City highlights.
Yeah.
Can't forget that one. And we go throughout Jersey, all the 5 boroughs, and cover all the different types of rocks: igneous, sedimentary, metamorphic. We got all 3 here in New York
Wow.
City.
Yeah.
They're just
All
much
right.
older than a lot of other places, and
Oh,
it's not as
really?
active.
Oh, huh.
Are
But
are our rocks older than like California rocks or
generally,
Colorado
yes.
rocks?
I mean, at the
Oh.
surface, generally, yes.
Hmm. Good. Hey, yeah, we have seniority. We get discounts at movie theaters because we got the older rocks.
We have mountain roots in the Bronx at Orchard Beach. Those are my favorite rocks in New York City.
Seriously,
Yeah.
this is real heavy geology right in the middle of the most populous city in the United States.
Yeah, you can go back a billion years in history just by
Amazing.
walking
Dang.
across the rocks in the boroughs.
Oh, I love
There are billion-year-old rocks within New York City.
that.
Exactly.
I love
Wow,
that.
that's incredible.
And
Because I know like the oldest rocks are only like 3 or 4 billion years, right?
yeah,
Yeah, well, our planet is a little bit over 4, right?
Yeah.
Parts of
So that's like a good chunk of the way back.
wow. Now, when you were in school, Sam, being taught earth science by those teachers, did you get a sense of all of this coolness that you are now able to give to these future teachers because of your additional learning and expertise? Or was that something that like you just picked up?
Well, I've always been interested in earth
Mhm.
science. I think one of the things that has always drawn me to earth science is that it's like very tangible and it's
Mm.
shiny. I mean, like, I feel like they're literally like everywhere around me. Wherever I
Yes.
go, I take them, and like, you can
Oh, yeah.
just hold them.
Wow. For those of you who are just listening to the audio, Sam is now holding a rock about the size of her head. Now, and what is that rock exactly? Show us what it is. It
Yeah.
looks like it has a bunch of little indentations. It's kind of dark. I'm almost guessing like it's a moon rock. I don't know.
Oh, I
Uh,
wish I had a
no.
moon rock in my hand. But there are some similar crystals that are in this rock that are also on the surface of the moon. So
Wow.
physics and chemistry work the same everywhere to our
Yeah.
knowledge.
Excellent. Glad to hear it.
So what kind of rock is that one?
It's a pegmatite, which is a type of igneous rock, and it's
Mhm.
got these
Okay.
really coarse crystals. But something that I really love about this rock, it's like coming apart in my hands even, um, are these minerals called micas,
Uh-huh.
and
Okay.
they grow in sheets. And they're the
Mm.
really shiny bits that you see. They're the
Mhm.
shiny bits that you see in the rocks in Central Park, which are, I see there's a
Ah.
question in the chat. Those are hundreds of million years old rocks in Central Park. Um, those shiny bits are also in makeup too. Synthetic micas are used to reflect light so that your skin
Oh,
Oh,
shimmers,
wow.
right?
that's
But
cool.
what's cool about how they grow is the sheets are very strong, so it's hard to break the sheet. Um, but the sheets stack on top of one another, and you can peel the sheets off of each other because they're held together
Oh,
by
wow.
weaker
So
forces.
they're paper thin. You can peel them?
Thinner than paper at times. Yeah, you
Wow.
can peel multiple sheets off at a time, but that's their atomic structure. That's how they grow. And
Wow.
when you get a number of sheets in a row, they look like pages in a book. And so the
Oh, that's
scientific
fun.
like jargon term for this texture is a mica book because it has many sheets of crystalline
Oh,
material on top
I
of
That's
love
it.
awesome. That's
that.
such a nice name.
I love that.
Yeah.
That's super sweet. I think that's great. Well,
I
I can
love earth science words.
yeah.
They're some of my favorite.
Well, I can
Yeah,
understand
it's fun.
why. We marvel at beauty. We always appreciate that stuff, and then you can tie it with terra firma, what we're actually standing on, and show them, check this out. Rock that's as thin as sheets of paper, thinner than paper. That's a kind of rock that we don't really think about on a daily basis. That's wonderful.
But we see,
Ah,
we use, right? Like
yeah,
it's,
yeah,
yeah.
yeah. Alan, give us another question, would you?
All right, let's go for another question. So this is maybe another sort of one going from history, geology type sort of things. This one is from Bianca, who is asking, how did global warming begin?
Ooh.
Oh,
Thanks, Bianca, for your question. Our globe generally warms and cools as planets do over their history, but the more recent warming started in like the mid 1800s to late 1800s when it really started picking up as humans have observed on Earth. And this observed because, or well, this started because of humans' contribution of what we call greenhouse gases to the
mhm.
atmosphere. And what this does is trap heat, making it really hard for it to escape. And in turn, creates this like positive feedback in our atmosphere and water and surface systems that keeps our planet a little bit warmer on average from year to year. Of course, you're going to have warmer and cooler days, but when we take our whole year and average the temperature over every day for a whole year, that's when we start to see the trend that we are warming.
Wow. So yeah, your point you made is important. I think you said that the Earth does warm and cool over long cycles, but from your scientific perspective, that warming and cooling cycle is not the same as the thing that we hear in the news called climate change. Is that right? That's a different phenomenon because I know there are some people who
Yeah.
will say, well, the Earth is just warming because it's just warms and cools all the time. But you're saying that this is actually a different thing than that kind of geological variation.
Yes, it is also called a crisis because that is what it
Oh,
is.
really?
Yes, the climate
Yeah.
crisis is what we are living in. Uh, is
As a
another way.
scientist, you're using the word crisis. I mean,
Yes.
that's actually kind of significant.
Yes.
Yeah.
Well, I think scale is really important, and sometimes time scales are hard to communicate to, uh, your friend, let alone an entire population,
Hmm.
right?
Yeah.
The 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 amount of warming that we're seeing directly related to our presence on this planet
Wow.
is critical for
Yeah,
our
I saw
species
that.
to survive.
Yeah, I
Amazing.
saw a really cool infographic from XKCD, I think, that was like showing like the speed of climate change in the past versus the present,
Mm.
and how it's like, you have this really big, tall timeline, and it's like got this really gradually sloping line back from several 100,000 years ago through, the geologic end of the last glacial maximum ice age type stuff, and then right at the end it just goes like zoop, and it's like, wait, that's a much bigger, fast
Yeah,
change than
that
it
would
has
be
been.
that would be us, the Zoop.
No,
Okay.
the zoop is us. Yeah.
Well, how much does volcanic activity put in terms of greenhouse gases into the atmosphere? Does it eventually, or does it typically, like drive the change in climate and temperature on the Earth? And are we basically outstripping that by human
Mm.
activity through all the things that we're doing to add carbon dioxide and methane and so forth?
There's evidence that really large eruptions have put enough carbon dioxide into the atmosphere to alter the climate system, right?
Hmm.
We have not witnessed a volcanic eruption at this scale. I
Okay.
feel like the more common super eruption imaginary scenario is like the really explosive one, like a Yellowstone event that happens
Yeah.
and you
Oh.
just like cover the planet in ash, or at least a large part of the continent, right? And that blocks out the sun. That could, ultimately result in a period of cooling, right? If you insert sulfur or aerosol particles that reflect light, right now you have a local cooling. We sometimes see that for the big eruptions that humans have witnessed.
Wow.
But yeah, I was going to say super eruptions can also be drippy, like how Hawaiian lavas come out. And those, if they last really long, they can let out a lot of carbon dioxide from deeper parts of our
this
Earth.
is something much bigger than anything. Like the biggest eruptions we've seen, thinking of like the one in Tonga a few years ago, maybe like Krakatoa, historically speaking. Like those are like small potatoes compared to the kinds of things you're talking about.
Yeah, so the Palisades Cliffs, glad we're back here. Those are associated with a super eruption scale deposit that covers, most of the northeastern part of the US and across and into parts of northern Europe.
Dang.
And even connects to volcanic activity that connects present day Brazil and Namibia, all related to the splitting of the Atlantic Ocean.
Those are all clumped together at the time?
Yep. Wow. So this is related to the rifting of the Atlantic Ocean and the splitting of Pangaea, right?
All right.
A lot of times these are associated with large outpourings of lava and gases that have been linked as well to mass extinction events, right? But we haven't witnessed that scale of an eruption as humans. So
if we as humans are making the same kind of effect with all of our carbon dioxide as something that caused a mass extinction event, and then that separate thing that did it in the past isn't happening, then we're probably the ones in fault for this mass extinction event, I guess.
That's yes, that is what is suggested.
That's the logic.
By the data.
Yeah.
Wow.
There you go.
And so could a Yellowstone event happen again? I mean, you should tell us exactly how big a scale. When you mentioned Yellowstone event a few minutes ago, it was really a matter of what? A massive explosion where Yellowstone National Park was that deposited like lava.
There were at least 3.
3? Uh-oh.
Yeah, in, the last hundreds of millions of years, right? But
okay.
So
I can still go visit Jackson Hole and enjoy myself and not worry about being blown up or anything.
You should take me with you. I've never been. I'd love to go.
But 3. Okay. Yeah, these 3 huge explosions, really?
Yes, that at least dispersed tephra that we can see today across most of what is now the continental U.S.
Wow. Okay, well, I won't worry about it because,
No, we would have like at least
a
year's notice.
Okay. So you guys can actually predict it. You guys will actually know, and we'll listen to you guys when it happens so that...
Hopefully we do listen.
Yeah, for that volume of magma to accumulate in the crust, we would expect there to be a signal at the surface, right? Gas chemistries can change, that bulging can happen, earthquakes, right? As the brittle crust breaks to make room for new volumes of magma to come in. Yeah, we can hear, see, smell.
Okay.
I wouldn't taste it, but
probably a bad idea to taste sulfur or whatever.
Yeah, no
I do know. Yeah, this is a thing. Like volcanologists who study like actual active volcanoes. Like what I hear about in the news, it's like there's a volcano that's going to erupt sometime in the next few weeks, but we don't know exactly when. So get out of the way.
Well, this is exactly what happened with you, right, Sam? Your research, like you are currently studying a volcano that is actively erupting, right?
I am, yes. So I made the shift from studying super eruptions for my master's degree to studying active volcanism for my PhD, and that's where I have landed now in my research pathway. I was really lucky to get to sample and work in coordination with the geologic agencies of Spain and the Canary Islands during the 2021 eruption at La Palma.
Oh, wow.
And that had both explosive and drippy, effusive habits to the eruption style. I did a lot of bucket sampling. So I was sampling airfall that would fall from the sky. And I'm hoping to do that again, like very soon as tomorrow.
So you just walk out there to the volcano with a bucket, like waiting for ash to fall in? Is that what you're doing?
A bit. You're not far off.
You go over and scoop some of the lava off. You get walk up to the shoreline and like scoop the lava and carry it with you with a bucket.
Yeah, I've done
Wow.
some lava sampling. We use a trident
Jeez.
for that, or a hook or a hammer,
Oh,
and
So some
then
piece
quench the
of
molten rock into a bucket of water.
all right.
okay. So when you're carrying it out, it's not liquid anymore. It's
No,
actually solid.
no.
Okay, it's a piece of
It's,
rock.
it's a rock at this point.
Okay. And
Yeah.
how do you get the
But
gas? How do you get the gas?
Oh,
I mean,
so
you'd breathe it in and hold your breath till you run over the side.
I would
and
not
blow it out.
advise that. No, I'm wearing protective equipment so that the gas doesn't
Yeah.
enter the harmful particles of volcanic environments don't enter, my respiratory system, right?
Thank goodness.
But
Yeah.
there are different types of canisters that you
Mm.
can put both on the ground and on drones. Even is where the
Oh,
research is going. Yeah, to sample and collect gas in the plume, because the chemistry of the gas and how it changes before and during and after eruptions help inform scientists on that
Oh, I
predictive
love that.
power for when
Okay.
eruptions start and end.
So,
Yeah.
so that's just great. You fly a drone over the volcanic stuff while it's coming up. Like you open up some sort of a canister, you let the air come in, you slide the canister closed, and then it comes back out, and then you
Yeah, it's
study it.
it's a mechanism that I'm not sure how it works. I have not done gas sampling by drone personally, but I know
Uh-huh.
that's where the field is heading. I've done a bit of some ground sampling of gases, but I mostly, I would say I'm like an ash lady. I am most, at least for
Very
now,
important.
right? I am like most interested in sampling ash airfall
Wow.
Okay.
from the sky, because we can, put a timestamp on when that was erupted. And what's important about that is correlating, any information that we can get from the ash itself, its chemistry, its texture, how bubbly it looks and porous. We can connect that to what the volcano was sounding at that time.
I see.
Awesome.
Yeah.
So you said that you're going like tomorrow?
I'm trying.
Tomorrow?
Yeah. So this is, volcanoes are hard to plan for. So
Very fair.
I've been kind of shifting my attention to the persistently active Reykjanes Peninsula on Iceland.
Ooh.
Okay.
And more recently, since December, it's been erupting at these kind of 1 month intervals over the span of a day or two. Makes it really hard to catch it before it stops erupting. But this current eruption that's happening as we speak is persisting stably in a stable sense for more than a week now. And so I'm hoping to link up with some collaborators at the university there tomorrow or the next day to probably set up a way to sample ash in the future. Hopefully sample some ash this next week and capture the end of the eruption. Generally, yeah, I mean, volcanologists might have trouble predicting exactly when and exactly where an eruption might happen, but there are usually, not always, but usually some signals that an eruption is imminent. And at least in the case of Iceland and in the case of La Palma, of the Canary Islands, there were no eruption-related deaths because evacuations were conducted safely and appropriately. But how long these eruptions last for is a bit of a mystery still.
Wow. Well, I am definitely going to make a trip to Iceland, but probably not for a couple years, because in 2026, there's going to be a total solar eclipse that passes right over Reykjavik. And so maybe we'll meet there, and hopefully the eclipse and the volcanic eruption can meld hand in hand, and we'll have a good time
as opposed
together.
to one making the other one.
Yeah,
that
would be
special.
bad. Yeah, I want to go back to your original music background. So, a lot of times we get a little worried that if we love the music or the art or something and somehow can't be scientists or the other way around, right? If you enjoy literature too much, then you can't be a laboratory specialist or something. But you're clearly the poster child for no, that's not true. How's the music still in your life? How are you doing? What are you doing? I mean, when you left the music, did it feel like leaving, or did it just feel like, hey, I'm going to put the sax down for a little bit and take it easy for a while and then come back to it whenever I feel like it. I mean, tell us a little bit about that.
Oh, I'm so happy you brought this up because it's such an important part of my life, right?
Yeah.
And it's shaped how I think, right? How I create, right? Our brain is capable of doing many things. And I think exercising different parts of our brain is never a bad thing. So for me, what makes me most excited about geology and earth science and pursuing science is how I can creatively craft together different types of data or even design an experiment, right? Experiment design in and of itself is inherently creative. So I've found ways to be creative within the sciences that are really rewarding, but it's not the same as, putting your kind of like emotional and personal experience into an art form, right? As scientists, we all kind of try to eliminate as much personal bias as possible, but we're still humans
Sure.
studying the natural world, so
Yeah.
that you can't get rid of it completely. But I think when you do pursue something more artistic, right, there you get that freedom to just do whatever you want.
Yeah. I
And
love
I
that.
think I put down the saxophone because at the time I was pursuing this like rigorous path of doubling in woodwind instruments, and
Oh,
I got very competitive
oh.
for different orchestras or small groups, or even what type of music to hone on and focus. And I found that it became more taxing than freeing at that time in my life, and so
Oh.
I just put it to the side. And music now comes back to me in different ways. I don't, play in the same way. I don't play the same types of things, right? But I've been really excited to think about how data and artists interpret volcanoes.
Of
Volcanoes make
course.
sounds. Anything that vibrates can be, pitched up or down to a frequency in which the human ear can hear. So we can even sonify most data sets. And by what I mean by sonify is you can take a squiggle
Yeah.
and run it through a speaker, right? If you set it to a frequency that the human ear can hear at. And so there's been some exciting work there. And, I think it was going out into the field to see a volcano and hear a volcano that got me really
Oh,
excited about
that's
Well,
sound
awesome.
again.
when you are up against a volcanic flow or something like that, or you're collecting ash with a bucket and the eruption's just over there, right? Not nearby, but over there. Can you hear the music?
It sounds like fighter jets. It's really
Whoa.
the sound. It's quite aggressive. Well, at least the eruption that I saw was quite loud at first, but
Wow.
some of the less explosive eruptions, ones that are more flowy, there was this sound. Oh my gosh, it was so cool. I don't know if you can kind of imagine this, but if if you could imagine what stretching glass could sound like,
Whoa.
that's what
Whoa.
a lava flow that's cooling sounded like, where it wasn't quite like cracking, but it had that like pitch to it.
Oh,
And as things rolled and moved, you get like the tink, 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 or even the ash on the helmet. And then as the
nice.
plumes exit, it's like really
Whoa.
strong. Yeah, there was this audio engineer that came out with us as part of the media crew for this Spanish eruption that was just collecting the sounds as data
Wow.
and
Wow.
That is
as
so
like a way to preserve the eruption as well.
in real time, right? Yeah.
Yeah, and it's
That is so cool.
as important of a sense as any other, I would argue. So
Nice.
I love that. And
That's awesome.
your experience with music gives you a unique opportunity to convey and to absorb and to analyze that in a way that maybe those of us who aren't as musically trained as you are can can enjoy. That's really cool. And you
Yeah.
can create it to your teachers and your future students and everything like that.
Yeah.
Oh, it's too much fun. I love it. I love it. Ah, uh, you know, Sam, we could go on and on and on. Well, we got to wrap this up. Can you come back sometime? Can we chat
I would
more?
love to. This was
Okay.
so
Yes.
fun.
Yeah. Especially if you get a chance to like wade through some more volcanic stuff, and you can tell us what that's all about. I would love to see
Yeah,
that.
I'd like to wade through more planetary volcanism.
Oh yeah,
I don't
yeah.
get to
We're
think about that as often.
well. Do it as
Very
often as
fun.
you'd like. We'd be happy here to chat with you. If you find out anything cool, let us know. How can we keep up with your work? How can we find you on the internet and things like that if we want to follow how you're doing and things?
Oh, a couple of different places. You can follow me at Sam Tram Rocks, ROX with X, on Instagram
Hey.
and on X.
Excellent.
I'm kind of building those profiles so they're in their modest stages of growth.
Okay.
If you are, a young undergraduate in earth sciences, I also have a YouTube channel called Earth
Oh,
Optics Mineralogy. If you need some help learning how to use the microscope to look at rocks, or you could just check that channel out if you want to see what rocks look like under a microscope.
marvelous. Thank you so much for that.
Yeah.
Well, this has been so much fun, and we will do it again. Dr. Sam Tramontano, thank you so much for being with us today. Thank you.
Thank you so much for having me. You guys rock.
From a geologist, that is high praise indeed. Uh,
Definitely.
Alan, as always, thank you so much. Really appreciate everything.
Yeah, glad to be
Yeah.
here.
And to all of you in our audience, thank you so much for having been with us today. If you like what you've seen and heard, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.